Hello friends, welcome to Caltex Academy. In this video, we are looking at the last part of this series, and that is question rule, and we have here question number 4. In case you haven't watched question 1 to 3, please go ahead and watch before we continue to this last part of the series. And in this question, it says, work out the equation of the tangent to the curve y equals to into 3x squared plus 1 over x plus 1 at the point 1, 2. So all you're working clearly. So here, what is the first thing we need to do? We first need to get the derivative of this curve, and then at this point we get a gradient, and by substituting this value of x into the gradient of this curve here, and at the same point the gradient of the curve is equal to the gradient of the tangent, and then we take this point as one of the points also that is lying in the same line, that is a tangent, and then we get the equation of that tangent. Minimum point of getting equation of a line, a straight line, is 1 point and then its gradient. So since the gradient of the tangent is equal to the gradient of the curve at this point, we can first go ahead and differentiate this function. So let's apply what I've just said in our working. So we can start by copying our question down here, where we have in the numerator 3x squared plus 1, and then we're dividing it by x plus 1. And then we can let our u as usual to be the numerator, and this time our numerator is 3x squared plus 1. And then we also let v to be our denominator, and our denominator is x plus 1. Now we can differentiate u with respect to x, whereby du by dx equals to the derivative of the first term here is 6x, and the derivative of a constant is 0. So let's also differentiate v with respect to x. Therefore, dv by dx equals to the derivative of x is 1, and the derivative of this one as a constant is also 0. Now we can state our formula, and please, for those one who already know about this quotient rule, you can substitute directly, but otherwise I am showing it to whoever is a beginner and is watching this video. So our formula is dy by dx is given by v times du by dx minus u times dv by dx, and we divide the whole of this expression by v, and v is squared. So with all this, we can go on and substitute our derivatives here into our formula, and that is dy by dx equals v is our denominator here, that is x plus 1, and this multiplies du by dx, and du by dx is 6x. Then we bring our negative to subtraction sign down here, and u is the other function up here, that is 3x squared plus 1. So we can write it down here, and we can open another bracket. So 3x squared plus 1, and then we multiply it by dv by dx, and then dv by dx is simply 1. Now we can close our bracket and go ahead dividing it with our denominator, and our denominator this time is v, because v is x plus 1, so we have here x plus 1 and then t squared. So we can go on and simplify the numerator of this expression. So we have dy by dx from the left hand side equals, we can open up this bracket, multiplying 6x by x to yield 6x squared, and then 6x times 1 we get plus 6x. Then we go on to the next side here where we have minus. Now we can write one bracket because we're going to open the inner brackets by 1, and anything divided times 1 is just itself. So we have here 3x squared plus 1, and then we still divide it by the denominator, and we can go ahead and maintain our denominator the same as before in our first point here, and that is x plus 1 we also square. So still we can go ahead and simplify the numerator, and then dy by dx is equals to, let's rewrite this one here, down here where we have 6x squared plus 6x, then we open up this bracket by negative 1 in front of the bracket, so we have negative 3 as a result of multiplying negative 1 by positive 3x squared. So negative times positive 1, we get negative 1. Then again, we divide it with our denominator, and our denominator is maintained the same way, that is x plus 1 and then is squared. Now we can simplify still the numerator because the leading terms are 2, so we need to make it 1. So dy by dx so will be equal to, now 6x squared minus 3x squared yields 3x squared, and then this term with the x is only 1, so we can copy it down here, and we have 6x and then minus 1. So again we can divide it by our denominator, and this time the same denominator passes where we have our x plus 1 also is squared. Now at this point we have got place our derivative, and then we can go ahead and use our point given to us from the question here to get the gradient function here. So let's assume this will have to be something like something like here. Then this is our point, and then under this point here we have a tangent, and this tangent at this point, the tangent and the curve are having the same point, maybe say P, with coordinates of 1, 2. So at this point the gradient of the curve is equal to the gradient of the tangent. So substituting this value into this gradient function here will get for us the gradient of the tangent. So putting this into practice, we can recopy our work here. So dy by dx, so saying here at the point (1, 2), it implies that our x coordinate here is 1. So wherever we get our x, we plug in 1. Now we have 3 into 1 and then squared plus 6 into also 1, then minus 1. So we divide everything here with, again, in the denominator we have x, and that x is 1 plus 1 and squared. So let's move on to simplify this work such that our dy by dx equals to, now 1 square is 1 times 3, we get 3 in our first term. So the second term we have 6 times 1, and that is 6 positive, and we copy also our negative 1 down here. And then from the denominator we can go ahead and simplify it, where we have 3 plus 6, that is 9, and 9 minus 1, we get 8 in the numerator. So somewhere let's first work on the denominator. 1 plus 1 is 2, 2 square is 4. So dy by dx is equals to, numerator is 8, denominator is 4. Then we can divide 8 by 4 to make for us 2. So dy by dx equals to 2. And again, dy by dx, since it is a gradient and in a straight line, we can use gradient as m. So m equals to 2. Now we can go ahead and have this point named as x1, then y1. So let's list them down here for easy substitution. Saying y1 equals to 2, and then x1 equals to 1, and then our gradient m equals 2. So we can substitute this one here to a formula, and this formula is y minus y1 equals m times x minus x1, where x1 and y1 are the coordinate goes from this point that is linking the tangent and the curve together, meanwhile m is our gradient. So y minus y1, and our y1 is 2, so m is also 2, and we have x minus x1 is 1. Then let's simplify this equation, the standard form of straight line, where it is in the form of y equals to mx plus c, and c is the y-intercept. So we can go ahead and open this bracket. The right hand side, where we have 2 times x, here is 2x, and 2 times negative 1, we get negative 2. And we can collect like term. From the left hand side, we are left with y, copying 2x down, and then if negative 2 crosses equal sign, it changes to positive. So we have here plus 2. And quickly we notice that positive 2 and negative 2 will vanish to 0, and then we copy the last result here, where we have 2x as the equation of the tangent. So please, if you get value in this video, go ahead and subscribe to this channel and share with friends, and don't hesitate to drop some comments in the comment section. I'll get back to you as soon as possible. Thank you for watching. See you in the next series. Goodbye and ciao.